The three most powerful passive component functions in electronics. Passive components are fundamental elements in electronic circuits that do not require a power source to operate. They can store, distribute, or dissipate electrical energy but do not actively amplify or switch signals like active components such as transistors or integrated circuits. The three main types of passive components are resistors, capacitors, and inductors. Resistors are passive electronic components that are commonly used in electronic circuits to control the flow of electric current. They resist the flow of current, and their primary function is to provide a specific amount of resistance in a circuit. Here are some key points about resistors. Function. Resistors limit or control the amount of current that can flow through a circuit. They are used to set bias points, divide voltages, and protect components from excessive current. Symbol. The symbol for a resistor is a zigzag line, typically with a label indicating the resistance value. Color code. Resistors are often color-coded to represent their resistance values. The colors indicate the significant digits, multiplier, and tolerance of the resistor. Ohm's law. Ohm's law, V equals I asterisk R, governs the relationship between voltage, V, current, I, and resistance, R, in a circuit containing a resistor. Types. Resistors come in various types, including fixed resistors, with a constant resistance value, and variable resistors, where resistance can be adjusted. Fixed resistors. Common types of fixed resistors include carbon film resistors, metal film resistors, and wire wound resistors. Variable resistors. Potentiometers and rheostats are examples of variable resistors. They allow the user to adjust the resistance within a specified range. Power ratings. Resistors have power ratings that indicate the maximum amount of power they can dissipate without overheating. Power is calculated using the formula P equals I squared asterisk R or P equals V squared slash R. Applications. Resistors are used in various electronic circuits, such as voltage dividers, current limiters, and biasing circuits. They are also found in amplifiers, filters, oscillators, and many other electronic devices. In summary, resistors are fundamental components in electronics, providing a controlled resistance to manage current and voltage levels in electronic circuits. They play a crucial role in shaping the behavior of circuits and ensuring their proper functionality. Capacitors are passive electronic components that store and release electrical energy in the form of an electric field. They are widely used in electronic circuits for various purposes. Here are some key points about capacitors. Function. Capacitors store electrical energy in an electric field when a voltage is applied across their terminals. They release stored energy when needed, providing a temporary power source for electronic devices. Symbol. The symbol for a capacitor consists of two parallel plates with a gap, and an arrow indicating the direction of the electric field. Capacitance. The property that defines a capacitor's ability to store charge is called capacitance, C, measured in farads, F. 1 farad is a large unit, so capacitors are typically measured in microfarads, μF, nanofarads, NF, or picofarads, PF. Types. There are various types of capacitors, each with specific characteristics. Common types include ceramic capacitors, electrolytic capacitors, tantalum capacitors, and film capacitors. Dielectric. The material between the capacitor plates, known as the dielectric, determines the capacitor's properties. Different dielectric materials have different characteristics, affecting factors like capacitance stability, voltage rating, and temperature performance. Charging and discharging. When a voltage is applied to a capacitor, it charges up by accumulating electric charge on its plates. The voltage across the capacitor is proportional to the accumulated charge. Capacitors discharge when the voltage source is removed, releasing the stored energy. Applications. Capacitors are used in various applications, including energy storage, smoothing voltage fluctuations, filtering signals, coupling and decoupling AC and DC signals, and timing circuits. They play a crucial role in power supply circuits, audio circuits, radio frequency, RF, circuits, and many electronic devices. Series and parallel configuration. Capacitors can be connected in series or parallel to achieve specific capacitance values or voltage ratings. Polarized capacitors. Electrolytic and tantalum capacitors are polarized, meaning they have a positive and a negative terminal. Connecting them in reverse can lead to failure or damage. In summary, capacitors are essential components in electronics, providing energy storage and performing various functions that contribute to the proper operation of electronic circuits. Their ability to store and release electrical energy makes them versatile components used in a wide range of applications. Inductors are passive electronic components that store energy in a magnetic field when an electric current flows through them. They play a crucial role in electronic circuits and are used for various applications. Here are some key points about inductors. Function. Inductors store energy in a magnetic field and resist changes in current flow. They are often used to control the rate of change of current in a circuit. Symbol. The symbol for an inductor looks like a coil or solenoid. Inductance. The property that characterizes an inductor is called inductance, L, measured in henries H. The inductance depends on the number of turns in the coil's geometry, and the presence of a magnetic core. Magnetic field. When current flows through an inductor, it creates a magnetic field around the coil. The strength of the magnetic field is directly proportional to the current flowing through the inductor. Self-inductance. Self-inductance is the property of an inductor to induce an electromotive force, EMF, in itself when the current through it changes. This phenomenon is described by Faraday's law of electromagnetic induction. Mutual inductance. When two inductors are in close proximity, the changing current in one inductor can induce a voltage in the other. This is known as mutual inductance. Applications. Inductors are used in various applications, such as inductance-based circuit elements, energy storage, transformers, oscillators, filters, and inductive coupling in communication systems. Inductive reactance. In an AC circuit, inductors exhibit a property called inductive reactance, XL, which is the opposition to the change in current flow. Inductive reactance is proportional to the frequency of the AC signal. Saturation. The inductance of some inductors can be affected by the saturation of the magnetic core material when exposed to high currents. Types. Common types of inductors include air core inductors, iron core inductors, and ferrite core inductors. Each type has different characteristics suited for specific applications. In summary, inductors are vital components in electronics, providing energy storage in magnetic fields and influencing the behavior of electrical circuits. They're used in a wide range of applications to control currents, transfer energy between circuits, and filter signals. Passive components are crucial for designing electronic circuits, providing the necessary building blocks for a wide range of applications. They contribute to controlling voltages, currents, and signal characteristics, and their proper selection and placement are essential for achieving desired circuit behavior.